Designforce is empowering designers in a wide range of engineering disciplines by bringing them optimization tools, high-performance computing tools, all on demand and over the web. Engineering design is a process whereby people are trying to work out how to build things. So if you take the example of a bridge, how big should that bridge be? How thick should we make it so that it doesn't fall down? And once we've worked out how to make it so it doesn't fall down, can we make it a little bit lighter so we use slightly less material? This was typically an iterative process, one that might be assessed by trying it, building it, and seeing what happened. More recently, people have been able to bring simulation or bring computers to be able to assess this for them. Once you're able to do that, the possibility of considering some form of optimization becomes possible. This can generate a huge amount of data. Single calculation can generate hundreds of gigabytes of data.
So one of the key challenges facing Designforce was how to enable our customers to really understand the data that they've created, in terms of how to visualize that data and how to seamlessly drill down into it so they can get a real understanding of what the data means. We've been working with Ajax for quite some time, and it had given us a lot of difficulties and a lot of headaches in terms of building a really rich experience. So what we wanted to do was investigate whether something like Silverlight would enable us to build a richer application. One scenario we were particularly interested in looking at was the idea of when an engineer has finished creating some simulations and they want to really take a deep look at them and then be able to exercise their design judgment. We thought that Silverlight might be a good candidate for this, so we opened up a dialogue with Microsoft to see how they might be able to help us.
My job is to work with customers and partners who are doing technically innovative or risky projects. There's 3 stages to that process. The first one is the architectural design session, where we spend 2 days in a room surrounded by whiteboards and basically do a big brainstorming session to work out what the scope of the project should be, what the application needs to do, and what the proof points are to show the technology is actually up to the job. Following on from that, we'll look together to put a development team together for a 3-week period, which is quite an intense development process, where we run a project very much in an agile way, in a Scrum style of delivery, where we're building that prototype application. The last day of that 3-week period, we typically bring the customer in and demonstrate that application to the senior stakeholders inside the organisation. Having such a short timescale to do the development in means that keeping the development team on track is quite an intense thing to do. One of the tools we use to ensure we're going in the right direction is a morning stand-up meeting. For me, as the architect, it's a perfect way of understanding what's going on in the team and making sure we don't have too many integration problems. This project's very much based on having a very rich user experience, and that involves having a different variety of skill sets. We've got our developers that build the back-end services and also the application logic. We also need user experience people that design what the interface should kind of look like, what data gets displayed on which screens and whereabouts it should be laid out. We also have designers that are responsible for doing the graphics, creating the assets and making the application look great. Typically, these people kind of a bit like chalk and cheese. They've got very different skill sets, very different interests, and work in very different ways. So it's very important to make sure that the tools and the process we follow help support these guys working together. And that really is evident when we talk about how the application should be architected, getting that split between what the designer works on and what the developer works on.
Neil asked me to join the project as development lead because I've got some experience working with a pattern called Model View View Model, working with Silverlight technologies and in particular working with designers. Model View View Model, in case you're not familiar, is a close relation, perhaps closest relation is Model View Presenter. And instead of having a presenter, we have a view model. And the biggest difference is instead of having the presenter talking back to the view in code programmatically, we have a view model, which is a relatively simple class that exposes some properties that the view binds to. And that's using the really powerful binding capabilities of Silverlight. And that gives us a really loosely coupled application, so the view is very loosely coupled. This is great because A, enables the developers to work with what is effectively a scaffolding, and then it's up to a designer to create the view, and he can do what he likes with that independent from that developer. It also enables us to find opportunities within the application. So we'd created a number of views that skin the view model, and then we realized that we could create different views that showed that data in a different light. Silverlight's luckless controls also added a huge amount to the designer's armoury here. We created the application with really basic controls, almost like a black and white application. They came in using Blend, changed all the controls, all the standard scroll bars, all the standard scroll viewers, list boxes, all that normal stuff, and created the finished look of the application, which I'm sure you'll agree looks awesome.
We're now in the playback session, which is where the stakeholders get to see the output of the POC for the first time. Here we're looking at the results of the simulations and looking at how changes in the design affect its quality. We can also capture images and add annotations to explain what we've discovered. We can also drive new simulations without having to understand the underlying technology which does the actual computation. We can view the data in a number of different ways in order to be able to understand exactly what's going on. Here we're using deep zoom to navigate around the design space quickly and easily. And we can also zoom in on any areas of particular detail that help us understand how changing the design affects changes in its performance.
I've thought this has been great today, really exciting. Seeing what we've got out of this, what's come out of this, those 3 magic buttons that suddenly can enable you to take your original design ideas, really see what the effects changes would have on that, find out how those different effects interact with each other, and give a good fast solution, completely flowing through from the beginning, very quickly, very interactively. It's just been absolutely mind-blowing.
In 3 weeks, a concept has been brought to the point where we can take this out and demonstrate it to customers with confidence. This is moving beyond software and tools and genuinely enabling them to make design decisions. I'm hugely impressed with what's been achieved in a very short time frame.
It's truly remarkable to see how Microsoft's tools, technologies and platforms can be used to solve really challenging engineering problems.